And today we're going to cover chapter 5. And the reason why I say today, hopefully you're taking these courses day by day. You should be going through the course, going through the videos, making sure you're understanding some of the material before proceeding to the next chapter. Again, everyone learns differently, so that would be my recommendation. I always talk about prerequisites. So basically, for the A+, it's a very technical type of exam. So you should have some familiarity with general networking concepts and terminologies, basic understanding or really knowledge of different types of networking hardware, such as routers, switches, and modems. Understanding what is the internet and how it functions, obviously a prerequisite. Basic understanding of what an IP address is and the role in network communications. Now, hopefully you went through my videos and it explained a lot more of this in detail. The goal here is you're going to go through the videos that's going to cover some of these concepts, and then you'll take this course, and then you'll take the practice exams that I do have associated with that. Also, you'll read my ebook. So a combination of different styles of learning hopefully will resonate as you take this course. Again, me walking through the material, a visual, and of course documentation to kind of back that up from that perspective. Ability to really navigate and perform basic operations within a computer or operating system, basic troubleshooting techniques for resolving common network issues, and knowledge of what a protocol is, an example of common protocol networks from that. So what we're going to do is cover a couple of things. We're going to compare internet connection types. We're going to look at TCP IP concepts. We're going to compare protocols and ports, and we're going to compare network configurations and concepts from this perspective. So the introduction is illustrated here. We're going to configure networking address and internet connections. So in this chapter, we're going to guide you through the various internet connection types, the basic TCP IP concepts, protocols and ports, and network configuration concepts. Hopefully by the end of this lesson, you'll be able to compare internet connection types, understand TCP/IP basics, be able to look at protocols and ports and understand the differences, and at least comprehend the various network configuration concepts. Again, the courses are prepped for the A+ examination, so look at it from that lens. So when you think about a course that's prepping you for an examination, it's going to really focus on the core concepts that's going to be on an examination, not to the detail level, from my opinion, that is going to really tell you step by step how to do things. Now, I do try to cover a lot of that, but I like to say you kind of learn through trial by fire a little bit, because it's not until you get into a situation, like I like to say, get your hands dirty, will you really get to learn the concepts from that perspective. All right, so let's talk about internet connection types. So there's various internet connection types. If you look here, my illustration, you'll have various internet connection protocols that are used. So if you look at what I wrote here, your internet connections vary widely, from traditional dial-up. Someone says, well, you don't use dial-up anymore. Actually, there are still folks that do use dial-up, and as well as some government agencies that still use dial-up, because again, it's the way it's kind of set up. If you think about wireless, you could get jamming service for wireless. There's different things that you could interrupt wireless with. So having dial-up is never a bad idea. Or the backup again. Normally you don't see that too much, but again, when all communication goes out, you still, dial-up may still work for you. So we talk about a modem. What does a modem do? Really, it really facilitates the connection between your local network and your ISP, right? It's going to convert those digital signals into analog signals and vice versa. So that's, if you think about the illustration here that I have here, you have your computer, you have your ISDN adapter, and then you connect to your ISP, and then from your ISP, back to the ISND adapter and then back to the computer from that. Now, if we move over to digital subscriber line, which is a DSL modems. So DSL modems provide really internet access through the telephone lines, which is going to offer high-speed data transmission over existing copper phone lines, and they're widely used for residential and small business internet connections due to their reliability and cost effectiveness. Now, again, if you think about technology and where we are, you may say, well, Paul, a lot of this is outdated. Again, the exam still expects you to have knowledge of these concepts. So again, as I illustrate here, you have your computer, you have your internet cord, you have a DSL modem, which you probably have in your homes today, and it shows a connection to the telephone cord. And then you have the phone jack and a telephone cord, again, to a fiber. The concept is still the same. You are plugging into a jack in your home. Your internet provider will come in, plug in the router, and he's plugging into some level of a DSL phone jack, and then from there, the communication is happening. Again, concepts as it relates to the exam and focus from that lens. So think of it from there. So if we look at and start to compare internet connection types, obviously we all know about cable modems, which majority of us still have in our home. Again, these are cable modems which uses coaxial cables to provide internet access. They are bundled with your cable television services, Affinity, etc. They also offer high-speed internet across the internet, mostly in urban and suburban areas, and they do provide a robust solution for home and small business network. So again, I run that in my home, but I also have fiber. So fiber to the curb, as they like to call it, FTTC, and fiber on premises, FTP, offers the high-speed internet by delivering fiber optic cables close or directly to your home. So the FTTC typically involves a fiber connection to a distribution point, while FTTP provides a direct link. I actually got both running in my home. I do have cable, and as a backup, I do run fiber. Actually, I should probably say I run fiber, and as a backup, I'm running cable. Again, just really understand those concepts from there. Then you have what we call a fixed wireless internet access. So fixed wireless internet really uses radio signals to provide internet access to a fixed location, like a home or office. This method requires a direct line of sight to a wireless access point and is a viable alternative in areas that lacks wired infrastructure. And then you have cellular radio internet connection. So cellular radio internet connection uses mobile networks to provide internet access. It offers mobility, allowing users to stay connected while on the move. So example, common technologies is 3G, 4G, and the latest is 5G. I do travel the country a lot, so sometimes I'm out on 3G, sometimes I'm on 4G. Obviously ideal, I want to be 5G where possible. So let's look at the differences from a 3G, 4G, and 5G. So 3G is really a third generation technology. It's really a significant leap from earlier models as it relates to data and mobile. It offers speeds up to 2 Mbps, which is going to enable video calls and mobile internet browsing. Now, it has been largely replaced, and it's laid the groundwork for the current mobile internet standards, which is now we're going to move into 4G, which is a fourth generation technology. It really improves the internet speed. It reaches up to 100 Mbps, and it supports HD video streaming, online gaming, faster web browsing. 4G is used today to provide a more robust, reliable internet connections for most mobile users. And of course, we move on to 5G. Again, fifth generation technology. It's the latest advancement in mobile internet. It offers really speeds that we haven't seen before, up to 10 Gbps, very low latency, and the capability or the capacity to connect more devices seamlessly is really has changed the game from the days of 3G or 2G, to be honest, from that perspective. And again, 5G supports all emerging technologies like IoT, which is Internet of Things, if you're in a small cities, and also autonomous vehicles that will help use 5G technology along the way. Moving on to a router. Now, a router obviously is a device that routes data between different networks. That's kind of how I look at it. When you see something on an exam and it talks about direction or path, look at if you see router in there, look at the definition of the question and how it relates to that router. Again, it's typically between a local network and the internet. It's a director. It directs traffic efficiently and often includes additional features like firewall protection and Wi-Fi capabilities. Moving on to firewall. A firewall is a security device that really monitors and controls incoming and outgoing traffic based on a predetermined security rules. Again, I like to use the highway, toll gates. If you think you go to a toll gate, you got to stop there. Normally, nowadays you have these passes that allow you just to kind of move through, but even the passes are doing the same thing. It's checking to make sure you are signed up. It's going to go green or red depending on what the license plate brings back to them. Same kind of concept with a firewall. You got a firewall and it's looking at traffic back and forth, and there's going to be rules. Rules might say, yep, go forward, or rules might say, go back. It's really, if I have here, it's a barrier between the internet, your internal network, and potential external threats. It's really going to help secure your communication. Because if you don't have that there, then you're allowing everything. Think of it, you're just allowing anyone to come in your home to do whatever. You're not asking any question. It's almost like you could be renting out a room and your people are answering your Craigslist ad and you're not doing background checks, you're not doing anything, but you're just saying, hey, here's the room, pay me the money. So again, firewalls do play an important role. Let's move on to TCP/IP concepts. So it basically stands for Transmission Control Protocol, Internet Protocol. It's really the fundamental communication protocol suite for networks. It allows a device to connect and communicate over the internet. It's ensuring data is sent and received accurately. It's understanding basic TCP/IP concept is really essential for a networking professional to really help them understand how to manage and troubleshoot the networking connections effectively. So here's just a kind of created a diagram here of TCP/IP model for protocols and addresses, right? So you have the application layer, we have what we call the transport layer, the internet layer, and the network link layer. If you take my Network Plus security, CompTIA security training, I do cover that in detail, the various layers. But let's focus on the A plus and some of the concepts you might see from an exam perspective. Internet layer. So the internet layer is responsible for the packet routing across the network. It uses IP addresses to identify devices and determine the best path for data to travel. This layer includes protocols like IP4 and IPv6, so it's IPv4 and IPv6 to be correct, which really handle address routing. And then you have the transport layer, which again ensures data is transferred reliably, accurately between the devices. It includes those protocols like TCP, which is a transmission control protocol, and UDP, which is a user diagram protocol. TCP provides a reliable, ordered, and error-checking data delivery of that data. With UDP, it offers faster but less reliable communication. I did create a video on this because I think the video is going to explain it visually so you get it in a little bit more than I believe I could explain it, because again, I believe a picture does paint 1,000 words, and I think this might be where it's going to help in this case. And now, application layer. So the application layer provides a protocol for specific data communication services on a network. It includes protocols like HTTP for web browsing, FTP for file transfer, and SMTP for email. This layer, really enables application to interact with the network. Let me talk about HTTP and FTP. These are unsecure protocols. I do bring them up here because you may still run into them from time to time, and it is still covered, I believe, on the exam. So HTTP does allow communication to flow, but it does not have the security layer that you would want as it's transmitting your data. So generally, you want to see HTTPS, and you want to see FTP, or really SFTP. So again, anything that you see an S, it generally means it's secure. So you have here SMTP for email. Again, that's a secure layer, a way of transmitting that data. IPv4 addressing. So this uses what we call a 32-bit address format to identify devices on a network. Each address is divided into 4 section or octals, as they like to say, separated by dots. So you have example 192.16.11. The IP4 provides approximately 4.3 billion unique addresses, which is essential for identifying devices in a network. What is an IP? Basically, it's the address to your home, I like to say. Think of it just like that. It is an address to where you're at, on where your device is on the network. And that's kind of the high level of it. There's a lot more to it, but that's kind of the basic. Now let's look at network prefixes. So your network prefix determines the division between the network and the host portions of your IP address. They're represented by a slash followed by a number. Again, example is /24. This notion helps define the size of a network and the number of hosts it can accommodate. Then you have IPv4 forwarding. It's a process of directing data packets from one network to another. It routes and examines the destination IP address in each packet and uses routing tables to determine the best path for forwarding the data to its destination. Again, there's a lot more to this, but again, I'm looking at from a prep exam, A+ exam prep. So again, those are just concepts you need to be. Okay, let's talk about private and public and private addressing. So public IP addresses are generally global and unique, and it's assigned by the internet using what we like to say is INA. So again, it's internet assigned numbers, and as you can see here from the illustration, it kind of gives you what I'm talking about from there. This really allows for multiple devices to share a single public IP address through what we like to say is the NAT, or the network address translation. IP4, which is a host address configuration, it assigns basically unique IP addresses to devices on a network. This can be done either manually, what we call static, or automatically, which is dynamic. Using protocols like DHCP, it's going to properly configure to ensure devices. So basically, I have here proper configuration to ensure devices can communicate within the network. So again, just something to understand those concepts. Now, moving further, looking at the basic TCPI concepts, you have the static host address, which is going to deal with the configuration, which involves manually assigning a fixed IP address to a device. It's going to ensure that the consistent connectivity is done in a manner that is going to that's going to help simplify the process. Moving on to DCHCP, it's a management protocol. think of it from there. It's going to dynamically assign the IP address to these devices. It's going to ensure devices can join the network seamlessly by automatically providing IP addresses, subnet masks, gateways, as well as the DNS server. So this is an example of what that does. You have the dynamic IP address, you have your server, and then you have the other version of that, which is the static IP address, which you have to do manually. Again, from an exam perspective, understand those meanings and those concepts from there. So if we look at our basic TCP/ICP concepts, let's cover these first two areas. So I talked about automatic private IP addresses. So the APIPA is a feature in Windows operating system that assigns a unique IP address from the range 169.254.0.0 to 169.254.255.255. When the DHCP fails, what happens here is this is going to allow the device to communicate within a local network area, even without DHCP. Again, it's a way for the assignment of those addresses to help basically manage the communication effectively. The other illustration you see here is basically related to a router configuration. It's going to involve setting up routers to help manage the internet connection and local area network. It includes the configuration of the IP address. So the DHCP settings allows for that wireless network, the security options, and port forwarding to really help optimize network performance. From an exam perspective, familiarize yourself with these concepts and what they do and how they work. So the IPv6 addressing uses a 128-bit address format. It significantly increases the number of unique addresses available, because if you think about it, at some point, if we didn't have this, we would just run out of addresses that we could assign to our devices. It really provides improved routing efficiency, security features, and the ability to really handle the growing number of internet connections. So IPv6 addresses are written in hexadecimal and separated by colons. So this is again just an example of what that looks like. Moving on, we're going to compare and look at protocols and ports. So think of the transmission control protocol as a way to basically determine how your data is going to be received at the other end. So basically, let's look at TCP. It's a connection-oriented protocol that's going to ensure reliable data transmission between two devices. It's going to first establish a connection and say, hello, this is Paul, are you there? Yep, I got it. And then it's going to basically provide a reliance that the data is going to arrive. So again, what it's going to do, it's going to establish a connection before even sending the data. Then it's going to guarantee that the data arrives in the correct order that it was sent. So it's really making it ideal for those data or those data attributes that require reliability. Now, let's say you are not too concerned with that, and you want to use speed is more of your concern. Then you're going to go with what we call UDP. It's going to help you connect protocols, or going to use connect. I have here UDP is a connectionless protocol that sends data without establishing a connection. So really, that's what it is. It's going to send the data, send it in speed, but there's no guarantee that it's going to arrive. But generally, for the most part, it should be okay. However, I would say if you're gonna really depend and rely on reliability of data receiving, then TCP is the way to go. If you're gonna do gaming or streaming, then UDP is probably okay. And again, here's just an example of how that's covered from that perspective. Now we're going to compare protocols and ports. So there are a couple of well-known ports. There's a lot more. I have here from 0 to 1023. The most common ones you'll see used a lot as example is port 80, HTTP, port 443, which is HTTPS for the secure piece of that. Remember what I told you, HTTP is not a secure protocol. HTTPS is. And then the port 25 is your SMTP server. It's going to allow applications to communicate effectively. Moving on, we're going to look and compare our configuration concepts, as I like to say, our network concept. So looking at DHCP leases, which is going to involve assigning IP addresses, and then dynamically it's going to assign them to a network device. A lease specifies the duration a device can be given an IP address before it has to be renewed. Because sometimes these things, not sometimes, they have to be renewed, ensuring efficient IP address management. DNS, which stands for basically domain name systems, allows for the translation from I like to say user-friendly URL. Think of it that way. Type in www.cnn.com. That's something that's very easy to remember, very user-friendly, like to say, or from a user experience, versus typing in 17.2.22.22.200, for example. Doesn't mean anything from a marketing perspective. It doesn't make sense. So that's really what domain translations will do. It helps the system, enables users to access the website using easy to remember names instead of numerical IP address, simplifying internet navigation. So if you think about DNS queries, so DNS queries are requested and sent from a user's device to a DNS server to resolve a domain name in an IP address. These queries really ensures users can access the website by translating the URLs into a corresponding IP address. And then you have your DNS record type. So these DNS records really store information about domain names, and their corresponding IP address. Common types include A record, which is IP address, MX record, which is mail exchange, CNAME records, which is basically a canonical name, each serving a particular purpose. Here I illustrate a little bit about a DNS lookup, what it does, and how it works. So again, just to give you some illustration, you have www.scalar.com. This is really the DNS numerical value of that, which is 192.0.221. And then you have a resolver that goes out and says, oh, okay, I see what you're doing here. Here's where you're trying to go. And then it really will do that for you from that perspective. Okay, again, concepts, understanding the meaning from that perspective. All right, so let's look at a DNS spam management process. So the DNS spam management process involves techniques to prevent spam emails from verifying a sender's name through a DNS records. These methods include SPF, which is Sender Policy Framework, and DKIM, which is a Domain Keys Identifier Nail, to help authenticate emails and reduce spam. VLANs create a segmentation of a physical network into multiple logical networks, improving management and security. Each VLAN operates as a separate network, allowing devices to communicate as if they were on the same physical network, regardless of their actual location. Again, you may want to put things in a VLAN just to safeguard any movement outside of that, in case you might have deprecating operating systems or software that you can't patch, but you still need that system running up. So VLANs do come in handy from time to time from that perspective. VPN is a virtual private network. Again, DNS spans management involved techniques to prevent spam emails by verifying the sender's domain through DNS records. Method includes SPF, Sender Policy Framework, and DKIM, Domain Keys Identifier. Again, concepts that's important to understand what they do from an exam perspective. Okay, this is just some questions that I put in here. Again, understand how and what they are in terms from an exam perspective. What are the main types of internet connections and their distinguishing features? And I have here, internet connections can vary widely from traditional dial-up to advanced fiber optic solutions. The main types include DSL, which uses telephone lines, cable, which also uses coax cable. Fiber optics, which offers the latest speed through direct fiber connections. Fixed wireless, which uses radio signals, and cellular connections, which leverage mobile devices. Each type has a unique advantage in terms of speed, reliability, and costs. What is the difference between public and private IP addressing? Public IP addresses are unique and routable on the global internet. They're assigned by the internet and assigned numbers authority, which is abbreviation called INNA. Private IP addresses, on the other hand, are used with local networks and are not routable on the internet. This allows multiple devices within a local area network to share a single IP through network address translation, which is NAT for abbreviation. It's preserving the limited pool of public IP addresses. What are VLANs and what are the benefits in a network configuration? Virtual local area networks, VLANs, segment a physical network into multiple logical networks. This segmentation improves network management and security by isolating the different types of traffic. VLANs allow for more efficient use of network resources as devices in different locations can communicate as if they were on the same physical network, reducing broadcast domains and improving performance. How does DHCP simplify network management? Dynamic Host Configuration Protocols, DHCP, automates the assignment of IP addresses, subnet masks, gateways, and DNS server information to a device on a network. This dynamic assignment eliminates the need for manual configuration. It reduces the risk of IP conflicts. It ensures efficient management of IP address pools, making network administration much easier and scalable. This next slide is really glossary of terms for you to study. I'm not going to go and read everything, but I suggest you could freeze this frame or just write it down. DSL, TCPIP, router, firewall, IPv4, NAT, VLAN, fiber optic, internet. These are terms that you will see in the exam. Please understand what they do and the concepts behind it. Thank you for attending Chapter 5, Lesson 5, however you want to put it. Again, please go through the videos. If you have any questions or you want further coaching on any of the information I provided, please reach out to me. I do offer one-on-one coaching sessions to really help you learn the material a little bit further. Or if you want me to focus on one other area, please reach out to me. Or sign up on the training platform for one-on-one session if you feel you need it. Again, go through the videos. Practice tests should also help you with the definitions and concepts. Some of the questions might be a little outdated. What I mean by that is CompTIA is always changing their exam, and rightfully so. But the concepts and the questions and the definitions generally are going to be the same. NAT is not going to change. Internet contour is not going to change. There's some foundational things that no matter how they change it up, if you understand the meaning of it, you should be good to go from there.